So this is where we were. We were in 6.8. We got to finish the complex numbers. I'd like to get 7.1 and 7.2 done today if we could. That's a big lot of stuff. Our practice exam is next Thursday. No, next Wednesday.
I was like, I'm not hearing Thursday.
No, that's when it is. No, yeah, next Wednesday is practice exam, and the real exam's 2 weeks from today. So another one's coming. All right. So this is the imaginary numbers, right? We were talking about numbers that aren't real. They're imaginary. So it's a pretty easy section, though. Just treat that I like you would an X. It's exactly the same. So what do we do when we have a minus in front of parentheses?
We distribute.
Distribute. Boom and a boom. So we get minus 4 minus 4i. We good so far?
Now collect like terms.
Yeah, then just like terms. 2 minus 4.
It's negative 2.
Negative 2. And then minus I and minus 4i. Just treat them like an X. It's minus 1i and minus 4i. So it's minus 5i. Is that good? We're done? It's all they want. So it's no big deal. Just treat this I stuff like you would an X. Just do the like terms. It's all the same. Good? Stop me if you want to talk about... Ooh, on number 9. Square root of negative 10 times square root of negative 7. Okay, so what have we learned about negative inside of a root? Can't do it, huh? So what do? You can't have negative in a root. So you pull it out as imaginary. We're using our imagination. It's not real, right? Square root of 10. Same thing here. Pull it out, and then the negative's gone. It's just a normal root 7, but there's I in front telling us it's imaginary. It's not real. Good so far?
The imaginary root of 10.
Now, remember how you multiply two root things?
That's the imaginary root of 7.
The insides with the insides?
Yeah. Right. Outsiders with outsiders, insiders with insiders. Right? Outsiders with outsiders, insiders with insiders. So I times I squared. Root 10, root 7. Well, that's just root 70, huh? Just 10 and 7 multiplied makes 70. Can we simplify that root 70? Nah. You can break it down if you want to. There's no pairs in there. 7 times 10, 2 times 5. So there's not 2 of anything. It's not going anywhere. Just stays root 70. Anyway, what about I squared? Any thoughts on I squared?
Oh, negative times negative is positive.
What's I itself?
It's imaginary.
I mean, what is I? Right. I mean, we're using our imagination, but exactly how are we using our imagination? What is I? It always reminds me of, sorry, I'll keep it quick, but it always reminds me of years ago, I mean, a lot of years ago, like 15 or 20, when our kids were little, my wife had a friend in a different town, and anyway, they had little kids at the same time. They'd go shopping at the mall and different places during the day. And this mom would always parent, this other mom would always parent by the threat of an invisible person. That's how she parented. One time the child was afraid of a man at a store or something like that. I can't remember what it was. So anytime the child was about to do something the mom didn't want, 3-year-old kid or 4-year-old kid or whatever, the mom would say, the man says no. Just like that. Because I guess her authority was not good enough. So she said, the man says no. And he'd always go, Mom, I want to do the man says no. Well, finally the kid got old enough, and my wife was there in the store with her friend one day when the mom said to the kid, the man says no. He wanted to run off and do something at the mall. The man says no, and the kid said, Mom, who is the man? Then she had to change her parenting techniques. Anyway, so what is the I? I mean, what is this invisible I? What is it? We need to know on this problem. What is the I? Well, let me help you. Let me lead you to it. Let's just go through a couple of these. What's the square root of negative whatever 3? Just the negative comes out, it's I, and the 3 stays in. You know that, right? Okay. What's the square root of negative 4?
Imaginary.
Negative comes out, it's an I, square root of 4. And what's the square root of 4? We can do that one, huh? We can't root 3, but we can root 4. So it's 2i, I2, same thing. It's 2i, right? Same thing. We can just root the 4. We couldn't root the 3. Same thing. All right, what's the root of negative 1? Negative comes out. That's an I. Square root of 1. What's the square root of 1?
1.
1. So I times 1 is?
1 I.
I. We found out what I is. What is I? Square root of negative 1.
I said 1.
Square root of negative 1. Right? We good? So we found I. That's who the man is, right? So the I is the square root of negative 1. That is what I is. Okay. Now, we're almost ready. We're ready to try. What's I squared? Well, isn't I squared I times I? We all agree with that, right? That's what I squared is. It's I times I. Okay, now, and what's I again? We just found I here. It is square root of negative 1. So I times I is square root of negative 1 times square root of negative 1. Good? Now, remember what we learned about roots. What's root 7, root 7?
7.
Plain 7. What's root 11, root 11?
11.
Plain 11. So if you have two identical whatevers in roots, one comes out. 2 for 1 deal at target, right?
Yeah.
It's the most fundamental rules of roots. 2 for 1. Got 2 7s in, 1 comes out. 2 11s in, 1 comes out. Do we change signs or anything? No, identical. 2 in, 1 out. Identical. You don't walk out of target and it changes. I bought two rugs at Target. I came out and it was 1 puppy. No, that doesn't happen, right? Whatever, same. Whatever, same. So 2 negative 1s in,
1 negative 1 out.
1 negative 1 out. That's what I squared is. Logical? Make sense? It's all imaginary, but logical? Is it good?
Is this
I
part of the
squared is
equation?
negative 1.
Is this part of the equation?
Well, yeah, we need this. Yeah.
Okay.
I'm not just playing games. No, we need this. Just telling stories. Yeah. No, we need this. So I squared is negative 1.
Okay.
I squared is negative 1. So what that means from this point forward, anytime, well, notice for a minute. Let me say it more clearly. Notice it's just a regular number. Now you can have, I can say I lost $1. You can do that, even though. Now you can't do square root of negative 1. That's imaginary. You can't say I've got square root of negative 1 quarters in my pocket. That's impossible. That's not a real life number. But you can say I lost 1 quarter today. Negative 1 quarter my bank account went down by. Right? You can do that. That's a real life number. Negative 1 is. Square root of negative 1 is imaginary. That's not real. Everybody see the difference? So I itself, plain I, is weird. It's just imaginary and strange. And so we're just gonna leave that I. We're not gonna mess with that because that's just weird. It's just imaginary and weird. But I squared, that's just a plain, everyday, normal negative 1. So anytime I see I squared, from this point forward, I will not leave it. I will replace it with negative 1. I'll leave i's. I'm not going to mess with them because they're weird. But I squared, that's just negative 1. So anytime I see I squared, boom, I'll replace it with negative 1. Anytime I squared pops up, I'll put negative 1 in its place because that's all it is. So here we go. I squared root 70 is negative 1 root 70. That's our answer. I squared is negative 1. But I, if I ever have an I, that'll just stay I. But I squared, that's negative 1.
Is that only for I?
You mean like, is it not for other letters? Yeah, we're just using I. I is the imaginary unit, square root of negative 1. I is imaginary, but I squared comes back into the real world. Isn't that weird?
Root. It takes, get it? Root.
It does. I like your pun. All right, so 2I times 9 minus 8I. So try that. Just do normal like terms. Just pretend that I is an X. Right? You guys get this. This should not be hard for you. This won't be hard for you. Just treat it like an X. Nothing fancy. The only new or weird thing is when I squared pops up, just replace that with negative 1. Everything else is just normal like what you would do with an X. So just distribute. They just want you to distribute. Just take that 2I, go boom, boom. Just totally normal like you would with an X. But if I squared pops up, put negative 1 in its place. Otherwise, it's just totally normal.
So, would it become negative 16 times negative 1?
Right. So 2I times 9, 18I, just normal, right? Nothing fancy. And then 2I times minus 8I, minus 16I squared. Good so far, just like I would with an X or any other letter. But I squared popped up, and the I just stays I, because that's just weird. We're not going to do anything with that. It's imaginary. But the I squared, that's negative 1. That's a real life number. So that'll become positive 16, and we're done. Is that good? So if you want to, guys, you can skip, and gals, you can skip right from here to positive if you want to. That's what I squared is always going to do, is just change the sign of whatever it's with, huh? Because it's just negative 1. It'll always do that. So it makes that negative 16 into a positive 16, huh? We good? All right. And how do they want you? They're a little picky on the way they want the answer. Okay, so 6 plus 2i, 4 minus 7. So just go ahead and do it. Just normal FOIL. Nothing really different, just normal FOIL. But when I squared pops up, replace it with negative 1. It's 24 minus 42i, boom, boom, plus 8i minus 14. I squared good so far, just normal, everyday FOIL. These two in the middle are like terms, huh? So they'll add, subtract, combine together. What is that, minus 36 or 34? Thanks. Minus 34i there in the middle. And then what about minus 14i squared? If you want to just make that plus 14, you're totally right. I'll do it more slowly. That I squared is a negative 1, which means it is plus 14, huh? But if you want to just jump right to plus 14, that'd be quicker. Right, everybody good with that? So it's totally normal, except the I squared, again, we replace with negative 1. And which means what? We have one more step of like terms, don't we now?
38.
The 14 and the 24 and the 14 combine to be 38. There we go. 38 minus 34i. Is that all good?
What branch of math are we going to be using this I in?
Yeah, maybe I'll show something a little bit if we have time. Something in the real world. All right, we good? Okay, so 3 plus 8i squared. Try that one. So, you guys moving along on this one? Can I just go 3 squared is 9? Can I just go, that's just 9, and that's just 64i squared? Can't do that, right? Is everybody okay? You can't do that. It's a real easy mistake to make. Instead, you have to actually write 2 parentheses and do the whole FOIL thing, right? So make sure you're remembering that. When a 2 is on a parenthesis, you got to write 2 parentheses in FOIL. So take it from there. The rest is normal. Boom and a boom. 9 plus 24i. Boom and a boom. Plus 24i plus 64i squared. Twenty-four i's 48i. And what do we do with that plus 64i squared? It becomes a negative 64, right? Because it's 64 times negative 1. I squared is negative 1. So that's really minus 64, and then that's some big number, I don't know. 55? There we go. Minus 55 plus 48i. Easy enough? Not hard, right? Even though it's imaginary.
Could you write it the other way too?
Yeah. Right, 48i minus 55, totally. Yeah, same answer, that's good. Yeah, good question. Order never matters as long as they have the right signs in front, exactly. Good, all right. Okay, so now we're dividing them. So have you noticed what we've done? We've added, subtracted, multiplied, and now we're dividing 2 complex numbers. So this is the 4th operator. So we've made up these new things called complex numbers. Complex number, this whole section is complex. That means a number that has a real part and an imaginary part. You with me? Like 8 minus 6i. That has a real part, 8. You can have 8 pencils in your pocket. And then negative 6i. You can't have negative 6i pencils in your pocket. That's imaginary. It's not real. So a number that has both a real part and an imaginary part put together is called complex. They have whole things you do. And I'll probably do, not 5 minutes, I'll probably do 2 minutes on Google when we're done with this. And I'll show you some of the real life uses of complex numbers. There's whole fields of it. Anyway, so there's these things called complex numbers. We've just made these up. We're in this new world called complex numbers. And we're learning to add complex numbers, subtract complex numbers, multiply complex numbers. We've done all that already. And now, finally, last step of the journey, how do you divide two complex numbers?
Wouldn't you divide like terms?
The thing you need to remember is what I is. What is I again? Who is the man? What is I? Square root of negative 1, remember? So whenever you look at I, keep in the back of your mind who the man is. I is the root of negative 1. Well, so what? So that means when I look at that I should be thinking, that's some kind of a root. That's what I is. No, I'm not going to put the root in there. Remember, we leave I as I. I only replace I squared. When I squared pops up, I'll replace it with a normal negative 1. So I don't mean I'm going to really put the root in there. But I'm just saying, have it in the back of your mind because that'll help you know what to do. If you're looking at that I, but both the I's top and the bottom, but especially the one in the bottom, and you're thinking, that's a root in the bottom, right? That's what I is. It's a root. What do? We've had previous sections and tests in which we dealt with roots on it was the last test, wasn't it? Which we have, what if I had like root, 3 over root, so what if I had a root on the bottom, like a root 7? What would you do? Times it, because we can't leave roots in the bottom, right? You would multiply by top and bottom by root 7, right? What if I had a 2 root 7 on the bottom? Well, same thing. No difference. Still just the root 7, top and bottom, right? But what if I had like a 2 plus root 7? Then they're glued together. See, over here, 2 times root 7, who cares? Just multiply top and bottom by root 7. We don't care about that 2 at all. But if it's 2 plus root 7, yeah, glued together. I can't just do root 7, that won't work. What do we got to do? Remember we learned this? To my opposite sign in the middle. Remember that? Called the conjugate? Remember that whole thing? That's what you got to do when you have a root with a plus or minus. When you have a root with a plus or minus on the bottom, glued together, you got to multiply by opposite sign in the middle, called the conjugate. Remember that whole section? Well, that's exactly, if you remember that, then it's nothing new. That's exactly what we have going on here. That I is a root. Just remember, I is really a root. So you go, they're just showing me a root in the bottom. I just do what I always do when I got a root in the bottom, along with a plus or minus. So they're glued together in the bottom. What am I going to do? Opposite sign in the middle, called the conjugate. I'm going to multiply by 6 minus 8i, top and bottom. Right? So that's why, because I is a root. And we got to get rid of that root. So let me write a note on that. When I in the denom, 2 cases. If there's plus or minus, also multiply by opposite sign in the middle, called the conjugate, just like we did before. If there's no plus or minus in the denom, only multiply by I over I. Does that make sense, those 2 cases? So, in other words, if this denominator just had an 8i, it didn't have a plus or minus, there was no Costco glue, I would just multiply by I over I. Just the root part, right? Just like we did a minute ago. 3 over 2 root 7, I would only multiply by the root 7, just the root part, not the 2 if there's no glue. Do you guys see how it's the same? It's exactly the same. We do with I what we've always done with roots. Am I going too quick? Do you see the 2 different cases? If you just have a root in the bottom with no glue, no pluses or minuses, no Costco glue, then you just multiply by the root part. So that'd be like 3 over 2i. There's no glue there. The 2 and the I are not glued. I's a root, but he's not glued. So I would only multiply by the root part, the I part. But if you have a plus or a minus with the I, with the root, then you got to multiply by opposite sign in the middle, the whole conjugate. Everybody seeing the difference on those? Whoops.
On the first one, it says if plus or minus, what is that?
Also. If plus or minus also, then also, comma, multiply by the opposite sign in the middle, called the conjugate. If there's no plus or minus in the denominator, only multiply by I over I. There is the difference. Okay, so let's do it. So, here we go. So parentheses, bunch of foiling, huh? Top and bottom. You got to foil. So boom, boom. Can you foil out the top and foil out the bottom and clean everything up? Big mess.
Oh,
Not too
it
messy.
simplifies really easy.
Yeah, it comes apart pretty nicely. On the bottom, boom, boom. 36 minus 48, boom, boom. Plus 48i, what's that, minus 6 squared. We good to there? That okay? I just foiled the top and foiled the bottom. Good. And so what does that mean? So 48. These combine, don't they? Is that minus 100?
Yeah.
100i. And what do you do with plus 48i squared? Remember, we never leave I squared.
It turns into minus 48.
Yeah, I squared is negative 1, so that'll be minus 48, won't it?
So 48 is not out.
Right. Everybody okay with that?
So it's
Remember, I squared is negative 1. We leave I as I, but I squared we replace with negative 1. Then on the bottom, these guys cancel, and we get 36
Get 100.
plus, plus. Everybody see why that's plus 64 there? Because again, I squared is negative
So
1.
you get 100i over 100.
We good? These 48s will drop out. Am I going too quick? So we get minus 100i over 100. The hundreds drop out, minus I. That's
The answer is minus I.
quite a simplification. That all broke down to just be, that means all this big thing is the same as minus I.
Well, if that's negative square root of negative,
We good there? Questions on that one?
wouldn't that be positive?
Good. All right. So I heard you asking. Square root is the two. You can't cross a negative in and out of a root. They stay separate. Oh, next. All right. So 3 minus 7i over 2i. Try that one. So when you see the I in the denominator on the next test, hopefully you'll remember. I know there's a lot to remember. Put on a 3x5 card. And it's a root. You look at it and go, oh, that's a root. That's a root in the bottom. That's what an I is. It's a root. So think, hey, what do I do with roots in the bottom? We had a whole section on that. What do you do with roots in the bottom? Multiply top and bottom by the root, right? Is there glue in the bottom on this one?
No.
No. So do you need both the 2 and the I? No. They're not glued together. Just the I, top and bottom. Right? Everybody seeing that? Just multiply top and bottom by I alone. Good. Look at those hundreds. 100 divided by 100. Yeah, there's I like an X. There's no glue. They're not plus or minus. There's no possibility to cancel those out.
Okay.
So just multiply top and bottom by I on that one. Top and bottom by I. And on the top, it distributes. So what do we get? 3i minus 7i squared over 2i squared.
So 3i plus I?
Yeah, so what do we always do with I squared? We never leave, we leave I as I, but I squared, those both change, they're -1, aren't they? That's -1, that's -1. So we get that. So far so good. It made that -7i squared become +7, and 2i squared become -2. Because I squared is -1, it switches the sign of whomever it's with. Doesn't it? We good to there? Now, here's where that's really a fine answer, and on the exam, it'll probably look just like that. But Math Excel is pretty picky. They want you to separate it and everything. So in other words, what they want you to do is they want you to go 3i over -2 plus 7. They just want you to separate it into 2 like that. That's what they mean by this a plus bi thing. They want it separate. They don't want it one fraction. They want it 2 separate. Let me see if they'll take exactly that. Let me see. It's 3.
Is there allowed to be a negative in the denominator?
Oh, yeah, there's no official rule that you can't put negatives in the denominator. Yeah, I know. Did a math teacher say that to you one time?
Yeah.
Yeah, I know a lot of people don't like it, but there's no official rule.
Oh, that's great.
Yeah, but having said that, it's true that most of the time they get rid of them. So yeah, and let me explain that because on the multiple choice test they won't leave them down there either. Yeah, so I'm saying two things. It almost sounds like I'm saying opposite, but it's okay. There really is no rule that you can't have a negative in the bottom. It is okay, but yes, usually they get rid of them. So because the multiple choice answers will probably do that, let me help you with that. What I would do with that minus, I would just pull it to the front, Remember, because a minus, top, bottom, front, it's all the same thing, right? So I would just pull it to the front, like that. Pull it to the front, like that. That's the same answer. Or you can put them on top. You can say, I'm going to put that minus 3i in the top. And I'm going to put that negative on top. Yeah, that's the same, that's the same, that's the same. They're all the same. Doesn't matter where, with a fraction, doesn't matter where the negative is. Top, bottom, front, it's all the same thing. But yeah, on the multiple choice test, you might get these negatives on the bottom. They won't usually put the answer that way, the publisher that makes up the multiple choice answers. So yeah, so make sure you know to do that so you grab the right answer. Good question.
Yeah, that's pretty much.
That it? Yeah. But as you saw, Math Excel does take it this way. Math Excel knows it's the same. Okay. All right, so we have 30 plus 5i over 30 minus 5i. Okay. So you got an I in the bottom, which is a root. You know what to do. Multiply top and bottom. Is there glue on this one in the bottom? Yeah, they're glued together. So you got to use the whole thing, opposite sign in the middle. Don't you? On that.
Multiply by the conjugate.
By the conjugate, right? Does everybody see we have to use the whole thing this time? Everybody see the difference? Last time, this one, see how the 2 and the I were not glued. So I only used the I. Everybody seeing that? When there's no plus or minus, no glue, you don't have to use the whole thing. Just do the I. But on this one, there's glue. These guys are all stuck together. You're shopping at Costco. You got to buy the whole package, not just part of it. So the whole thing there. So you're multiplying by opposite sign in the middle, the conjugate. Like that. Like that. Multiply both those. Good. So 30 times 30, 900. Plus 150i, and boom and a boom. So plus 150i plus 25i squared. Good so far. On the bottom, boom, and a boom. 900. It's 150i, boom, boom. Minus 150i. Minus 25i squared. We good? And then the bottom of these will cancel. And then you know the I squared pieces are -1, aren't they? So we never leave I squared. Those are -1. They switch the sign of whomever they're next to. So that'll be what? 300i, these guys make 300i. Minus 25, right? They switch the sign. Over 900 plus 25, they switch the sign, don't they? So what is that? Some big number. 875?
75 plus 300i over 925, I think.
Yeah, it looks like 925. Now, we can't leave it that way. But everybody good to there for now. Good to there? Is that all making sense? Yeah, why can't we leave it that way? What's wrong? Well, remember that there's the Costco glue up here, so I can't just do 2 of them, but I can do all 3. Remember, it's all or nothing. If you can do the whole package, you have to do it, right? So remember, they're glued. So are all 3 of these guys, all 3 divisible by the same thing?
Yes.
Yeah. For sure 25 goes into all of them, right? Right? $8.75, that's a bunch of quarters. $9.25, that's a bunch of quarters. $3, that's a bunch of quarters. You know 25 goes evenly into all those. Use your calculator, right? Divide them by, if you weren't sure, you could have done divide by 5. But for sure at least 25 goes. Divide them all by 25. And I'm going to get 37 plus, how many quarters in $3? 12, right? And how many quarters in 9.25? There's 37. Oh, I did the other one wrong, that means. 35, yeah. They can't both be the same answer. I knew something was wrong. Yeah, thanks. 32, 35. Yeah. Everybody good there? And that's it. There's nothing more we can do. Oh, they make us separate them, actually. Yeah, I forgot. We have to separate them. I forgot all about their pickiness in this section. They want me to separate them. There's the answer they want. Separate them into 2 fractions, right? They don't want it 1 fraction. They want you to separate them.
Is it going to be 1 fraction or 2?
2.
Normally on the test?
Oh, the test will be 1. The test will be like that. Yeah.
So if after, by any chance, you've separated them, and those separate ones can still be...
Go further, you do it. Good question. Yeah, if after separation, one of them can do more, then you do it. And that happens sometimes. Yep, good question.
Is that last term that you wrote 12 over 37 and then I, or is it 12I over 37?
Remember, that's the same thing. To be in the front is to be in the top. Either way, it's all good. Yeah, good question. That I could be in the top or the front. It's always the same, right? Top and front are the same place, aren't they? Because it's over 1, right? Okay, so last one real quick. So 7 over 8i. What would I multiply by on that one? Just the I. Good. They're not glued, are they? So I don't need them both. Right? Everybody good with that? So that'd just be 7i over, and what would the bottom be? 8i times i? 8i squared. And what do we do with I squared? -1, so that's -8. Done. That quick. Right? When they're not glued, it's a lot easier. Plus the minuses make all the problems, don't they?